Eighth grade, oh, sorry about that. Seventh grade math, test 27, study guide, problem number 1. Lauren poured 2/5 cups of bleach into a bucket. Then she poured 6 cups of water. Using this ratio, how many cups of water will there be for every 1 cup of bleach? Okay, so we're going to do the unit rate. And we want to know per cup of bleach, or we say bleach second or bleach last. So the way we do that is we take the first one and divide by the amount of bleach. 6 cups of water goes first, bleach goes second, and always by dividing the first one by the second, you'll find out how much for each one or per unit of the second. So in other words, bleach goes last because they mentioned bleach last. So we divide these two. How do we divide by fractions? We multiply by the reciprocal. We flip that fraction upside down, do our factor trees, cross out our ones, and we know that 15 cups of water for every 1 cup of bleach. Number 2. For number 2, we have to decide which of these tables are proportional. So, since we learned slope is y over x, I'm just going to stick with that. I'm going to put y over x. I'm going to put the bottom numbers over the top numbers and see if I get the same thing every time. So if I take the first point, which is 7/5 is my x and 14 is my y, and I put y over x, that means y divided by x, or 14 divided by 7/5, which again, dividing fractions means to multiply by reciprocal, where we do our factor trees and cross out our ones again, and we see that that ratio is 10. So let's look at the ratio for the next point. The next point in the table is x is 7/4 and y is 35/12. So we'll take y over x again, which means y, write y first, over means divide by 7/4. We divide fractions by leaving the first one the same and multiplying by the reciprocal, flip upside down, the second one. Factor trees again. 35 is 5 times 7, 4 is 2 times 2. Cross out our ones. Anything on the top and the bottom gets crossed out because 2 over 2 is 1. 7 over 7 is 1. Cross out our ones. We learned that in class. Multiply whatever's left, and I also get a ratio of 10. But we want to check all three because it is possible that 2 might work and then the last one doesn't work, and if that's true, it's not proportional. So we're going to test them all, in other words. So I'll go ahead and take the last point that they gave us for that table. The last point they gave us, the x is 7/3, the y is 70 over 3. Y over x means y divided by x. I write the y first, I do division, I do the x second. Multiply by reciprocal. Factor trees. Cross out my 1s. The 3s and the 7s get crossed out. What's left is a 10. I have the same ratio every time. Every time I put y over x, I get the same number or same ratio, which means that that first table is proportional. Now we have to test the second table. Same as before. I'll take y over x. The first point I get is 2/6. If I put 6 over 2, or 6 divided by 2, that's 3. So I got a ratio of 3. Next point, they give me a 4 for the x and 8 for the y. So I put 8 over 4. I get a ratio of 2. I can stop right there. I have to get the same thing every single time, or else this relationship is not proportional. Only table 1 is proportional. Problem number 3, we're going to have to solve this equation right here. And I'm sorry, it's actually an expression. We're going to simplify this expression and then see which of the 4 given expressions are equivalent. So I see plus and I see a negative, but it's still an addition problem. So I see plus and I see plus again. So I don't need to do rule for subtraction this time. There are no numbers right in front of the parentheses. You see that negative x is not right in front of it. It's separated by a plus sign. So in other words, I don't need to distribute, so I just combine like terms. So all of my x's are like terms. I have 1 negative x, 10 more negative x's, and 10 positive x's. I'm going to add up my teams. I have 10 positive x's and a total of 11. Because if I have negative x, that's negative 1x. So I add that to negative 10x, I have a total of 11 negative x's. Now, to simplify this, combine these two. Opposite teams mean subtract. So 10 take away 11 is 1. But who has more? Negatives have more, so it's negative 1x, which is written as negative x. There's only one constant. There's only one number without any letters, right? There's only one constant, so I don't need to add that to anything. So this simplifies to negative x plus 7. Now we're going to check the others and see what they simplify to. So the first one is already simplified for us. That's not the same thing. The 7 is the same, but the coefficient is not. Expression 2, that's simplified. That is the same thing, so we have to pick an answer that has expression 2 as part of it. Expression 3 is not simplified, so we're going to simplify that. I'm going to combine like terms. I get negative 11x plus 1. That's not the same. And expression 4, again, we need to simplify. This time I'm going to add the two constants, the two numbers. I got a negative 4 and positive 11. If I do teams there, I get a total of 7. Negative x plus 7 is the same thing. So the expressions that were the same are expressions 2 and 4. So we're going to use distributive property to answer number 4. And it says which expressions are equivalent. This time they give us 3, but we got to simplify the given expression in the question first. Since I have a subtraction problem, I'm going to do the rule for subtraction. And now I'm going to distribute. You're going to go out to the side and do 5 times 1.25. You should get 6.5. Over here, positive times negative is negative. 5 times this is negative 11 and 25 hundredths. So now we look at expression 1. Expression 1, switch the order. If I switch the order, I see that my 11 should be negative, their 11 is positive, so expression 1 doesn't work. Expression 2, their 11 is negative, and their 6.5 is positive. Expression 2 is the same. Expression 3, I got the right signs, but the b is on the wrong number. So expression 3 doesn't work, so this time only expression 2 works. So it is possible that 2 or even all 3 could work, so don't assume that it's always going to be 1, right? We never assume, we always check. Okay, so the next problem, we're on number 5. So for number 5, they give us an inequality. We're going to solve it and explain what the solution looks like if we were to graph it. So we work farthest away from the variable, do inverse operation. The opposite of positive 29 is negative, but I got to do it to both sides. Here I use teams again. Opposite teams mean subtract. Negatives have more. Now I divide both sides by 5. I don't reverse that inequality. I don't flip the mouth the other way because I didn't divide by a negative. I divided and there was a negative, but the number I divided by isn't negative itself. So the inequality stays the same. So this is read x is less than negative 5. That means my answers are everything smaller than negative 5. Well, here's negative 5. It doesn't include it. That means an open dot because there's no line underneath. So that's open dot. Everything smaller on the number lines this way. So those are smaller numbers. So the description of that is D, which is an open dot on negative 5 arrow to the left. So problem number 6, we have a couple prices here and taxes. So Margie paid $150 with 6% sales tax. So if I find 6% of $150, I can add that on to $150 and find out how much Margie paid. So I cross multiply and divide, and I find out that there was $9 in sales tax because 6% of $150 is 9. I add that on, $150 plus 9, and I see that Margie paid $159. So now we're going to look at Jimmy. We're going to find Jimmy paid $120 plus 7% sales tax. So let's find 7% of $120. Cross multiply and divide, and I see that 7% of $120 is $8.40. So remember, dividing by 100, we move the decimal 2 times. That would make that 8.4, or $8.40. I add that on to 120. He paid $128.40. Together, the question says together. I have to add these two together to get my answer of $287.40 together with taxes. Number 7, we have to add these fractions. I know how we love fractions, so we're going to go ahead and take these, get a common denominator for these two. First time these are the same is 4, so I'm going to multiply this by 2 over 2. So 2 over 2 means 1/2 is also 2/4. It's the same number. And I have negative 3/4. I do the rule for subtraction here, plus 5. I'm going to combine these two. Common denominator means I can add the numerators and keep the same bottom number. So I keep the 4 on the bottom and I add 2 plus negative 3. That's negative 1. So I got negative 1 over 4. Now, if I'm going to add negative 1/4 to 5, that's 4 3/4. There's a couple ways you can do that. So one way you can do that is you can take it, and the way I taught you in class is the same way we would multiply these numbers, which is to make this into a fraction and first. Now when we're adding, though, we'd have to get a common denominator, so I'd multiply this by 4/4, do teams, and then I can divide in and out, take my remainder, put it up top, and that's another way to get 4 3/4. See the 3 and the 4? It'd be 4 3/4. The other way to do it is this. Now, another way to say 5 is 4 and 1. 4 plus 1 is 5, right? Another way to say 1 is 4/4. So you can say 5 is 4 4/4, or 4 plus 1 is 5. And the reason we want to do that is because we're going to combine the fractional part. So the fraction part, negative 1/4 plus 1/4, if I take away one of those, I get 4 3/4 that way also. So either way you want to do it is fine. Okay, so now we're on number 8. And for problem number 8, we had a scale drawing, and the scale was 1 to 6 1/4. And then they said you have one shape here. It was mapped to figure B, or this is the first one, this is the second one. And how does this become this? Well, if a scale of one of these is 6 1/4 of these, I just multiply those two. So when we multiply fractions, we make everything a fraction, convert this. 4 times 6 is 12. 4 times 6 is 24. 24 plus 1 is 25 over 4. That's the same as 6 1/4. Make that into a fraction. Do your factor trees, cross out your 1s, multiply, and that's a finished answer. If you don't see your answer as an improper fraction, you can convert. So we go in and out. Again, the remainder goes up top. Divisor goes on the bottom, and that's how we get this number as a mixed number. Number 9. It says a circle has a circumference of 156 3/100 centimeters. Well, circumference is found by multiplying 2 pi r. So if they give us a circumference, we know that c, or the number they gave us, equals 2 times pi times r. Well, pi is about 3.14. So 2 times about 3.14 is always 6.28. You can even memorize that, right? I said that in class. Want to memorize that? So I can get radius by isolating the r. I divide both sides by 6 28/100, and we're using calculators on this problem. So we round that to the nearest hundredths. So my radius is about 25 85/100, which is what I need to answer this question, because this question asks us if you found the area of the circle, but only 2/5, 2 out of 5, 2/5 of the circle is shaded, what's the area of the shaded region? In other words, we've got to find the area using this radius and then find 2/5 of that number. So, find the area, which is pi r squared. It's about 3.14 times, remember we found the radius using this up here. So I'm going to square that first. Put that in your calculator first. Type that in, this times itself. Then you can multiply it by 3.14. Leave that in your calculator. Then hit times. Now we're going to do 2/5, right? To do 2/5, hit this number times 2 equals. Then divide by 5 equals. Round to the nearest whole number. You should get 776 centimeters squared. Next problem, number 10. So for number 10, we had to find that composite area. So that little square up top is a 6 by 6, so that's 36. Now, if I separate this here to this rectangle right here, then I go this times the length. However, the length's not 52. 52 is all the way. This length is the same as the distance here. This is 16 plus 6 plus 16. So once I get that, I multiply it by 20 to get this area right here of that rectangle. So I add those up, I get 38. 38 times 20. So the area for that part is 760 square units. So this is 760. This one here, the little one, is 36. So now I got to find the triangle. Now the triangle, I need the base and the height. They got to be perpendicular to each other. I wouldn't use this right here. Okay, I got to use these two numbers. So this one I already know is 20. This one I have to find. All the way is 52. From here to here is 38, so if I subtract 52, take away this part that I don't need, take away 38, I'll have that base of that triangle. So I take 52 minus 38, so the base of the triangle is 14. The height is 20 from the drawing. I go base times height, but then I have to remember to divide by 2 because it's a triangle. So the area of the triangle part is 140 square units, and I add those up to get my answer. Number 11, we have a rectangular prism. In order to find the volume, we have to go length times width times height. But they knocked it over to try to confuse us, and they made this height, they called it the length. Okay, and they called this the width. Okay, so what we do then is we just read this problem and decide, all I need to do is find this length and this length right here. This distance from here to here and this distance, and then multiply those three. So what I do is I look at just this bottom part right here, and they say this has a perimeter of 56. So perimeter is, for a rectangle, is you just take 2 of the widths, or 2 of one side, right? And 2 of these, and add them together. Okay? Because it's all the way around. So if I got this, I'm going to have this again. If I got this, I'm going to have this again. That's where the formula comes from. So perimeter, they said, is 56. We're finding the W because they called it width instead of giving us a number. And they gave us a length. So I multiply those two, solve this equation to find W, or to find, I have this one, but I need this one to find this one. So I subtract 24 from both sides, divide by the coefficient, and I figure out that this number down here is 16. So now I have everything, I have all the measurements for the base, but I need to get this measurement here, right? And they tell us in the problem that that is 3 times this. 3 times the one I found. So I take that and multiply it by 3. And I see that that's 48, this distance. And I just multiply those two together to get the volume, which is 9,216 inches cubed. Number 12. Adam's using a shovel. Okay, and the amount of volume that he scoops on average each time would fill a box, and that means rectangular prism. That's 3 by 4 by 2.8, which is great because it's kind of hard to find the volume of a round scoop of dirt. But if it's the same as a box is easy. A box is just length times width times height. So I multiply the volume of the measurements that they gave me, and I figured out that each scoop is about 33 6/10 inches cubed. The whole, well, it's not perfect, but the whole is the same amount of volume as another rectangular prism that's 20 by 20 by 30. So in other words, if I multiply those three, I would get a volume of 12,000 inches cubed. The question is, how many scoops or how many of these would it take to fill this up 70%? So I got to find 70% of 12,000. 70% of 12,000, since we're using calculators, we're not going to use the percent proportion. Instead, we're just going to go 0.7 times 12,000 to get 70%. So in other words, how many of these to fill up 70% means how many of these goes into this. Goes into means divide. You already have this in your calculator, so hit divided by 33 6/10. And you're always going to round up, right? Because even if it mathematically rounds down, the whole still won't be full 70%. So we would always round up in that problem to get 250 scoops. And it might have worked out perfectly, I don't know, but you would always round up either way. So 13, the table shows the results for a spinner. It says, give the number of times the arrow of the spinner should land on red 150 spins. Okay, so we're talking about red. So we got to get our proportion from the table first. Red is 10 out of 50. That's a proportion. So the question is, how many reds out of 150? So we just write a proportion, right? So from the table, the ratio is 10 to 50, or 1 to 5. I can write 10 to 50 equals how many reds out of 150. Then I just cross multiply and divide. And I find out that it would be about 30 times. So for 14, a coin is flipped and a number cube is rolled. What's the probability of landing heads, then an even number? Well, heads is 1 out of 2, because there's only one side that has heads out of 2 sides total, even though there's 3 even numbers out of 6. So the probability of rolling an even is 1/2, or 1 out of 2 also. But the probability of this and this means I got to multiply my two probabilities, and I found out it's 25%. 15. Jake performed an experiment where he picked blue, brown, purple, and green marbles out of a bag 100 times. Okay, each time he replaced the marbles, these are independent events, and then they give us his observed frequency. So he noticed that he had 3 times as many blue as purple. 3 times as many blue as purple. Okay, so let's start looking at our options. So A, if we look at blue and purple, blue is 46, purple is 15. That's about 3 times as many. Because if I took 15 and multiplied it by 3, I'd get 45. So that's about right. Doesn't have to be perfect. The next one, B, 25 purple, 25 blue. Well, that's not 3 times as many. C, 10 purple, 31 blue. That's about 3 times as many. So it could be A or C. It can't be B. And D, 5 purple, 38. Well, that's not 3 times as many. That's like 7 times as many. Okay, so we know that it can't be B or D, so we can cross those out. So it's got to be A or C. So now we'll read the next part. The next part says this. He noticed his observed frequency gave him green about a third of the time. Well, these are 100. Remember it says that 100? Or you can add them up to the calculator to get 100. A third of 100 is about 33. So A has about 33 green. C doesn't. So the answer has to be A. 16. 50 teachers are asked who they liked out of this list. So we're going to pick out which statements are true. So, statement 1. Okay, statement 1 says this. 16% prefer George Michael. Well, if we look at the table, we see that there's 16 out of 50. But 16 out of 50 is not 16%. 16 out of 100 is 16%. 16 out of 50 is like 32%. So that's not true. Statement 2. Out of 200 teachers, 14 would like Stevie Wonder. Well, 7 out of 50 like Stevie Wonder. So 7 out of 50 like Stevie Wonder. The question is, would 14 out of 200 like Stevie Wonder? In other words, are these proportional? And if I did a cross multiplication here, I would see that they're not. Or if I look this way, 14 is 2 times bigger than 7. 200 is not 2 times bigger than 50. So that's not true. Statement 3. There are twice as many teachers who prefer George Michael over Adam Levine. Well, 16 prefer George Michael, 14 prefer Adam Levine. There are 2 more teachers, but not twice as many. That's not the same thing. Twice as many, you would take this and multiply it by 2 to get 28. So that's not true. Okay, so far as nothing's working out. Hopefully statement 4 works out, or we did it wrong somewhere. We got to go back and check, right? If that happened. But let's take a look. Statement 4 says this. For every 42 teachers that prefer Adam Levine, 39 will prefer Katy Perry. So they're saying 42 out of 39, Adam Levine to Katy Perry. So we got to look at our table and see if we got the same ratio. On the table, we had 14 for Adam Levine, 13 for Katy Perry. So the question is this the same ratio as this? In other words, are these two proportional? And if I did cross multiplication here, I'd get the same thing. Or if I saw this is times 3 and that's times 3 also, then you could say it's proportional. So statement 4 is true. Number 16. Okay, so 16, we have a double box plot. And they're talking about Dr. Newton there and Dr. Smith. And then we have some numbers down here. And it says the box plot shows the number of minutes the patients had to wait. And question 1 says this. The interquartile range is the same for both. Interquartile range means you go to the ends of the boxes, go down and see those numbers, and if you subtract those two, do you get the same number? Well, I can physically see they're not the same. Dr. Newton, his first quartile there is 10. Dr. Smith is also 10. Dr. Newton's third quartile, the end of the box, is right after 20. Dr. Smith is after 25. So I know that they're not going to be the same when I subtract those numbers. So A is not true. I don't even need to do any work. I can just physically see that. B, the median for Dr. Smith is 15. So I find Dr. Smith. I go right to the middle of the box and I go down. That doesn't hit 15, so that's not true. C, there is a greater variation in recorded wait times to see Mr. Smith. Well, the variation means the difference between the big and the small, right? So if I look at those, I can see the variation or the distance between the big and the small for Smith is greater than Newton. So that's true. And D, let's see, which problem we're on here, 17. So that one's true. D says there is a greater consistency in the distribution. Greater consistency means this, that they're like symmetrical, okay? So like, if I look at this one's not symmetrical. This is not consistent. Like this range here is small, this range here is really wide. Okay, so this one looks a little more symmetrical than this one. But the statement says that this one is more symmetrical than the top one. That's not true. So the answer is C for that one. Okay, number 19. The double dot plot shows the daily temperatures for two cities for 15 days. Compare the centers of variations of the two populations. Centers of variations. It means like median or mean or average, right? Which of the following inferences or statements that we think is true about the populations is correct? Okay, so we're going to read these and see which is true. It says both cities have the same variation. Both cities have the same variation. Okay, well, if I look at the highs and the lows for Lanston and the high and the low for Zaslow, I would see that, you know what, those are not the same. Okay, so that didn't work. B, it says I hope I'm saying that right. Lanston has a greater mean low temperature than Zaslow. Now that gets confusing because they say me and then they say the word low. But I gotta be clear here. They're saying that these are low temperatures. So don't let the word low confuse you. So let's just read it without saying low, okay? And it says Lanston has a greater mean. So the mean is in the middle, right? If I go in the middle of all these, I see that Lanston's average is 54. Zaslow average is 60. Zaslow's higher. B is saying Lanston has a greater mean temperature than Zaslow. That's not true. Okay? So C, Zaslow's low temperatures center around, so now don't get confused with the word low again. They're not talking about the last one over here and here. Okay? Again, because these are low temperatures. So let's read it without saying the word low. Zaslow's temperatures center around 54. So here's Zaslow. Go to the center. Is that around 54? Nope, that's at 60. So hopefully it's D, or I missed one. Let's try D. Lanston's low temperature, let's just say Lanston's temperature center around 54. So here's Lanston. Go in the center. I go down. It hits 54. D is true. That's our answer. All right, so number 20, we have three triangles together that make 180, or they are supplementary angles. So we have one that's 90 degrees, another one that we don't know, so we'll call it R, and a third one that's 52 degrees. But all three together make a straight line. So this and this and this equal 180. I can figure out the missing angle by simplifying this equation. Add my two like terms. 90 plus 52 is 142. And subtracting to isolate the variable, I see that R is 38 degrees. And we are done. Hope that helped you guys out.